So, good morning, students. Welcome back to the video lecture series on our unit number 3, that is transient overvoltages and the flickers. So, this is a simple diagram, single line diagram demonstrating the principles of the overvoltage protection, where we are using the arresters basically, which is diverting the surge current to the ground, then bonded at a local ground references, external signal cable, and low pass filters, and the position of the lightning arrestor, LA, surge arrestor even. So the main function of the surge arrestor and a transient voltage surge suppressor, TVSS, transient voltage surge suppressor, is to limit the voltage that can appear between the 2 points in the circuit. One of the points to which arresters or the surge suppressors are connected is frequently the local ground, but this need not be in the case. Keep in mind that the local ground may not remain at a zero potential during transient impulse event. Surge suppression devices should be located as closely as possible to the critical insulation with a minimum of lead length on all the terminals. While it is common to find arresters located at the main panel and sub-panels, arresters applied at the point where the power line enters the load equipment are generally the most effective in protecting that particular load. In some cases, the best location is actually inside the load device. For example, many electronic controls made for service in the power system environment have the protectors like MOV arrestor, metal oxide varistor arrestor, the gaps, Zener diodes or surge capacitors. Okay. In this figure, basically, here is the shown the arrestor connected location. So that figure indicates that first arrestor is connected from the line to the neutral ground bond at the service entrance. It limits the line voltage V1 from rising too high relative to the neutral and ground voltage at the panel. When it performs its voltage limiting action, it provides the low impedance path for the surge current to travel towards the ground. Note that the ground lead and the ground connection itself have a significant impedance. Therefore, the potential of the whole power system is raised with respect to that of the remote ground by the voltage drop across the ground impedance. For common values of the surge current and ground impedance, this can be a several kilovolts. What is a flicker basically? An impression of unsteadiness of visual sensation induced by the light stimulus whose luminance or the spectral distribution fluctuates with the time. So basically, rather than going for the flicker, let us see this is simple, the lightning arrestor. So power circuit is nothing but it's a feeder. There is a spark gap, a nonlinear resistor, and again which is connected to the ground. So when there will be a high strike, that is the lightning strike, the surge current will pass to the ground. That nonlinear resistor is nothing but when there is a nonlinear resistor is like when there is increase in the current, the resistance get decreases, and when the current is at a nominal value, the resistance get increases. There is a nonlinear resistance. There is a lightning arrestor. So let us see now voltage flicker in detail. So just read the slide. We shall discuss the voltage flicker in our next class.